conclude our discussion of functions, I want to talk about overloading functions and a little more about scope. You should have already reviewed the first 4 videos on functions prior to watching this video. Let's get started. I've created a program here and I added one function called computeMin, which all it does is return the minimum value of 2 numbers. This function does not handle if the 2 numbers are equal. If I were adding comments to this function, I would include a note in the assumptions and limitations that I do not handle numbers who are equal in this function. I will continue describing exactly what this function does. All I'm doing is passing parameters by value to this function called computeMin. They are both integers. If num1 is less than num2, then I'm going to return parameter 1, a string. Otherwise, I'm going to return parameter 2, a string. I'm going to initialize my numbers. I is 12, j is 7, x is 1.1, y is 1.4. I'm going to execute my first call to the function here, and I will return either parameter 1 or parameter 2 right here. When I execute the function using real numbers, even though I accept only integers, we will see what the answer is returned from this computeMin function. So I'm going to run right now. So the minimum value of I, which is 12, and j, which is 7, is parameter 2. J is the second parameter. Now let's step into the function and see what happens when I pass real numbers to a function that only accepts integers. I'm going to step into. Notice both num1 and num2 are 1. It seems to have truncated both numbers, which in fact is what happened. The compiler has cast, which means converted the double into an integer. And the way it did that, it just dropped the decimal part of the number. So what's going to happen? 1 is 1. 1 is equal to 1. So what are we going to get out here? Let's see. Let's step over. And in this case, we get parameter 2 is less than parameter 1. That is not the case. So what do we have to do? C++ allows us to overload functions. You could consider function overloading the same as a homonym. You can consider function overloading someone like homonyms, 2 words that sound the same but have different meanings. As example, the word 2. That can mean the number 2, or it can mean also. So I'm going to copy this function and overload it. The way I overload a function is I use the same name for the function. However, my parameter types are different while the variable names remain the same. I'm going to pass doubles to this routine. So the only difference between the function that begins on line 8 with the function that begins on line 20 is the parameter list, the types of the parameters passed in. I will call this the signature line. Now, how does the C++ compiler know which compute min I'm calling? Well, it looks at the signature line and compares what you're passing to compute min to what the actual parameters you are passing. If I'm passing two doubles to compute min, I'm going to execute this function. If I'm passing two ints to compute min, I'm going to execute this function. Let's see this in action. I'm going to set my breakpoint here also, going to run. Now my breakpoint is at line 37. I'm going to step into, and we will step into this function, compute min, beginning on line 8, which we do. And let's make sure our output is correct. The minimum value of I and j is parameter 2, that is correct. Let's step into again. And make sure we execute this compute min. And we do because x and y are the actual parameters, and x and y are both doubles. In this case, we should return that x is, or parameter 1 is the minimum. Let's step, and of course parameter 1 is being returned. The minimum value of x 1.1 and y 1.4 is parameter 1. So this is called function overloading. The compiler determines which function to call based on the parameter list. The function name is the same, except the parameters types are different. And the compiler determines which function to call based on the actual parameters going into the function. If the actual parameters are integers, I will execute the function beginning on line 8. If the actual parameters are doubles, I will execute the function beginning on line 20. Now, I've talked about scoping in previous videos. I'd like to expand on that just a little. We know that because of scoping, num1 and num2 are only visible in this function. I cannot access num1 and num2 here. They do not exist. Num1 and num2 only exist in this function. Likewise, I, j, x, and y only exist in main. I, j, x, and y do not exist in this function. We could take that further. We have a variable defined inside two brackets. We do something with this variable. We can output it, and we can see that it's changing, which we will do in a second. And then we're going to see something after we exit this while loop. So what do you think j will equal when we exit this while loop? Let's see. Let's pull this to the side. We are currently right before the while statement. Let's step. Okay, in this case, I've actually stepped into something I really don't want because it jumps somewhere else. So I'm going to step over and see when I come back. This is unfortunate. Sometimes this happens. I think in this case I will just stop the debugger and rerun. I'm going to set my breakpoint here, continue, j is 12, j is 11, so j is definitely decrementing. Once I equals 0, we're going to exit this while loop, right? So let's watch I down there below, right here. I is now 3, 2, 1, 0. And what do you think j equals here? Let's step over, and j is now 7. So this j I've defined in between these curly braces overshadows the j here. I initialize the j equal to 1 here, so that completely overshadows this j. This j still exists, however this j is being used. When I exit this while loop, this j is no longer in scope. We return the scope to this j defined on line 34. So when we output j equals on line 48, we get 7. This concludes this video on function overloading and additional concepts of scoping.